We didn't start the range yet, we should. So let's do now the range of a matrix. And the range is defined as the, so if we have a matrix which is m by n, okay? The question, so in principle, I don't memorize them, okay? I cannot even memorize this, for example, what is the domain, what is the dimension of the range and the domain, but let me ask you this. What do you understand from the linguistic, actually it's also terminology in mathematics. What do you understand when you say range? What is range? Or what is the relation of the domain with the range? You have heard this domain and the range? What is one and what is the other?
Yes, we've heard those.
Okay.
The domain is the set of numbers that define a function, and the range is the image produced by those domains.
That's true. So the domain, you pick up some values here and you go to the range, okay, using a function f of x. So it's something like y is equal to f of x. This is the, I think this is the domain, and this would be the range, right? And now this function f of x, in this case, is a matrix A, which is transforming the values in x linearly, using linear relations. So the range, apparently, now when we talk about the range of matrix A, we are really talking about the values of y, okay? So this is the range of matrix A, and we are assuming that, so this is really domain, we pick up some numbers here, and maybe the range is like here. So maybe the range can be a line, okay? It can be a plane. So how can we draw a plane here? A plane can be something that is shown like this. So probably we have function f1, it is projected into a line, or we can have another plane, sorry, function f2 of x, where the projection is a plane, okay? So it would be that the range of f1, it can be dimension 1, or the range of f2, it can be of dimension 2. And now let's see what we have here. So let's see how the range is defined. So for any matrix n by n, so this is how we generally denote it, the range of A is defined as R of A. Okay, so this is how we write it down, and the R of A is equal to all the possible values AX. Okay, such that X is an element of what? So X, what is X? Rm or Rn? So A is n by n. If A is n by n, what is the dimension of X? N by 1, right? Would you agree?
Yes.
Yes. So X is Rn. Good. And what is the answer B? This is n by 1, right? N by 1. So then it looks like this is a subset of Rm. So this is how we can define. So apparently we multiply with any vector x, and but x is not a single vector. It's like three variables. Imagine for a moment that you have three variables and you are trying to see where you are projecting some knowledge. Let's give an example because most probably things will become much clearer. So let's assume that we have a matrix A which is defined as 1, -1, 2, and 2, 3, 1. And then we have a vector x which is equal to x1 times x2. Okay, the next question is obvious. What is the range of A? So let's have a look. What is the dimension of A? Dimension of A is 3 by 2. The dimension of X is equal to 2 by 1. So then the answer vector, what is AX? What is the dimension of A times X? What is the dimension here? It is 3 by 1, right? So then let's multiply them. Let's see actually where does the range go. So we have here 1, 2, minus 1, 3, 2, 1. We multiply this with x1 and x2, and this would be equal to what? Can you help me here? What is the answer here? Would you agree with this? Minus x1 plus 3x2, and we have 2x1 plus x2. Now, this one, we can write this one also as follows: x1 minus x1, 2x1 plus 2x2, 3x2, and just x2. Here we have 1 minus 1, 2. So we're factoring out what the x2 is. This is 2, 3, 1. So what do you observe here? It looks like the range of A is a linear function of the columns of A. So when we started the first session today, we said that the rank is something that you learn or you obtain the piece of information from working with the rows. But when it comes to the range, we have to work with the columns. So x1 and x2, you can assume like this is a free variable, which is like S and T. So here we can say that x1 is a real number R1, which means that you can think of anything like from minus infinity to infinity. This is x1, and x2 is the same. So it looks like this is going to be the range. Now, let me ask you the following question. So a classical question is the following. Is 1 minus 1, 2 in the range of A? How can you answer this?
I think yes, because we can obtain this vector by making x1 1 and x2 0.
That's true, 1, 0. So let me write this here. We get this if you multiply with 1, 0. Okay, 1, 0, this denotes the coefficient. What about 3, 2, 3? 3, 2, 3. Is this in the range of A? Think about this one.
Yes, it is still in the range.
Why? 1, 1. Which means that if we add up these two columns, we get this value. What about 5, 5, 5? What can you say about this? Is this in the range of A? How can we figure it out? So let's say that you have 1 hour to think about, but what would be your approach? How can you test or how can you check whether this is in the range of A or not?
I would equal this to x1 to that equation.
Okay.
And then I'll try to find x1 and x2.
That's correct. So we equal these and we say if we can find a value of x1 and a value of x2 that satisfies this equation, then this 5, 5, 5 is in the range of A. 5, 5, 5 is actually a very interesting component, which is a clock. In electronics, it's an integrated circuit design, which is like a clock. You can search this online, IC 555. In the second year, you might memorize is 741 is another component, 555 is another one, which are very standard products which you can buy at the store for 30 cents. For half a euro, you can buy the product. But now let's go back. Let's see if this integrated circuit component 555 is in the range of A, which means that can we find x1 and x2 which satisfies this condition? How can we do that? How can we solve this one? What is the best approach to solve this?
We do the Gaussian elimination, like we
do the Gaussian elimination of what? Where shall we start?
You make the augmented matrix and then you simplify it.
That's correct. We make the augmented matrix. Okay, if we have any, so this looks like sometimes it might look like difficult, but we make the augmented matrix. So help me, Ron. So what is the augmented matrix here?
Wait.
And
231 and 555 now.
That's true. 5, 5, 5. Okay. Then let's move a little fast. How do we make this 0? We can add the first two rows, right?
Yes.
Okay. This is 1, 2, 5, and here we have 0.
0, 5, 10.
Thanks. And then we start twice. So we do 2 minus twice the first row. This is minus 3. 5 minus 10 minus 5.
Minus 5, yeah.
Okay, and then what can we do? Can we divide this one by 5?
Yes, so you get the leading one.
Then we get the leading one, this becomes 1, 2. So this is easy. Let's make this 1, 2. What is the next step? We can do row 3 star would be equal to row 3 plus 3 row 2, right? And here we would get 1, 2, 5, 0, 1, 2. Let's not forget these are the leading ones. And then we get here 0, 0, minus 5 plus 6, 1. This is what we get. What can you say now here?
This is the row echelon form.
Yes, it's a row echelon form, not the reduced row echelon form. Because we have here leading ones, and we can make this 0 and these two 0. We can do that. But how can you read the last equation here?
It means that there's no solution because it's
Exactly.
0 cannot be equal to 1.
Yes, because 0x1 plus 0x2 is equal to 1, which is not possible. So what does this mean? This means that this system has no solution. So 555 is not in the range of A, okay? Not, let me write here, in RA. Okay? Actually, what about 554? What can you say about this? 554. 554.
Can I ask you a question, Professor?
Yes, yes.
How did we get that 3 to 3 is in the range of matrix or equation?
Say it again, how did we get?
3 to 3, we said that is in the range.
Oh, 3 to 3 is, wait a second, this is 3 to 3?
We asked if that is a part of the range. It's not part of the solution.
So, this one, potim diyelim, kto tylko donat, potim diyelim te dwie, aż ty. Okay, so if we add those, if we set x1 is equal to 1 and x2 is equal to 1, is it clear now?
Understood. Okay.
Okay, good. It looks like 555 is not in the range of A. What about 554? This is in the range because we can set x1 1 and x2 is equal to 2, and we can satisfy the equation. Okay, so 554, this is in the range, but 555 is not. Actually, if you want to produce a vector which is not in the range of matrix A, you just add them together and you just change one number. So what you can do is that you put 1 and 2 you add those, you get 5, 5, 4. So this is in the range of this. Then how can you make this one? How can you produce a vector which is not in the range? You just change only one entry. Këtë katër bëhet 5, jam I sigurt që s'ka përqen në range në as. Okay? I just hope you are following carefully. Okay. So the power outage. Okay, then so let me use this. I need this part of the board. We still keep track of the same equation. But now let me ask you this question. So this is A. Okay. Now, what can you say about A1 if A1 is equal to 1, minus 1, 2, and 2, 3, 1? So far, we have not changed it much. And 5, 5, 4. How does the range of A1 compare with the range of A? So we're asking this question. How do you compare range of A with the range of A1? So what is the range of A? The range of A is S times, so S is like a free variable. We can call it x1 or S. 1 minus 1, 2, plus T times 2, 3, 1, okay? And here, this would be equal to S 1 minus 1, 2, plus T 2, 3, 1, plus K times 5, 5, 4. So, how are they equal? Which one is larger? A range of A1 or range of A? Which one can cover a larger range when it is projected?
A1, because it has more parameters.
It has more parameters, okay. But why don't we look at this one? In fact, this system, now this is 554, right? Allow me to write this one instead of 554. Let me write here. What was it? It was what 554. What was it? I think we wrote it here. It was 1, 2. This is equal 1 minus 1, 2 plus 2, 2, 3, 1. Okay? Would you agree with this? 554, it was in the range of A already, which means that 554, it can be written as a linear
So
combination.
they both represent planes.
Say it again?
They both represent planes?
Yes, they do, yes. But which one is larger?
So does this mean they're equal in that sense? Because since it's part of...
Yes, they are equal. The range of these two matrices, they are equal because this third column is not adding any new information. The third column is already a linear combination of the first two, right? It's the same logic when we say that if we have three equations, but one of the equations is a function of the other two, so we don't really have three, we have two. Similarly, this 5, 5, 4, this can be described as a function of these, okay? And if you notice, these are the same vectors. So the range of A and the range of A1, they are equal to each other. Is it clear? Now, let's assume we have another matrix, A2. We haven't done it, okay, A2. And assume that A2 is 1, minus 1, 2, and 2, 3, 1. And we add 5, 5, 5, 5, 5, 5. How would you compare range of A with the range of A2?
The range of A2 would be larger than the range of A.
It would be larger, right? That's true. Now, what is the range of A2? The range of A2, now allow me to write it like this. Let the first column be vector V. Let the second column be vector W, okay? And the third column, let be the vector Z. The range of A2, this is written as S times V plus T times W plus K times Z. Okay, this is plus. So just have a linear combination of all of these. And actually, before a while, you said here that the range of A and the range of A1 is what? It's a plane, right? So this is a plane. Would you agree? And here,
Now we have a
say it again.
now we have a three-dimensional space.
Exactly, that's true. So this one, this is three-dimensional. Why? Because we have two vectors that can define a plane, and now we have another vector which is not in this plane. If this is not in this plane, we can produce a three-dimensional space. So this is 3D. But we can also say the following. We can say that the range of A2, whenever K is equal to 0, this would be equal to range of A, right? Only when K is equal to 0. So when we are not using this, they will be the same. But the moment K is different from 0, of course, this is larger. So this is only at the single point, it's equal. Or when you set K equal to that specific value. Now, let me ask you this question. Or let's use this part of the board. Is 1, 0, 0 in the range of A? Is it in the range of A? What do? We draw AB as Luke was suggested to us. So let's solve this one here. We're solving this question. This is 1, minus 1, 2, 2, 3, 1, 1, 0, 0. Let's get the reduced row echelon form to simplify the problem. 1, 2, 1. We add the first two equations. This is 0, 5, 1. Then here we get minus 2, 0, minus 3, 0, minus 2. And then what is left is that we can do this 1, 0.2. We divide by 5, 1, 0.2. And then what can we do next? This is 1, 2, 1. We keep this the same, 0, 1, 0.2. And then we add up the third row, we add 3 times the second row. Okay, so we do minus 3 plus 3, 0, 0, 0. And this is minus 2 plus 0.6, we get minus 1.4. Okay? Then we can divide this. Actually, we can divide this by minus 1 over 4. What do we get here? We get 1. What can you say at this stage?
That it is not in the range of
Yes.
A.
Why? Because this system here, let's not forget, this is A, okay? This is A, and this is AB. Let's not forget this. So what is the rank of A? Rank of A is equal to what?
Rank of A is 2.
That's correct. This is 2. What is the rank of AB?
It's 3. So
this is we have no solution. So we have no solution, which means that we can never find a constant number that multiplies the first column plus another constant number that multiplies the second column that would give 1, 0, 0. Okay. So this is no. The answer is no. So is this in the range of A?
I ask you why rank A, B, C?
Say it again.
Why rank A, B, C?
Rank of A, B is 3. That's a good question because we have 3 leading ones. Okay.
The third one, I guess, is not leading. We don't have zeros upper part.
No, this is leading. For the AB, if we have a matrix which is 3 by 3, this is a leading coefficient, a leading one. It's even holding a very good lead. It is leading.
Because, okay, I may be confused, but I know that to have leading ones, we should have the other zeros, if I'm not wrong.
Well, you want to say that this is not reduced row echelon form yet. This is row echelon form.
Okay, okay. So, okay, understood. Thank you.
So we can, yeah, thanks, but we can do a couple of more operations using this one to produce zeros here, but I think this will remain here. We can never erase this one anymore. This will stay there. So rank of AB is 3, but this means that this is no solution, which means that we cannot find two constants, that if we multiply the first and the second, we can never get 1, 0, 0. That's good. What about this? Is 1, 0, 0 in the range of A2? How would you answer this? What would you say? Again, the same. How do you solve the problem? We construct the augmented matrix 1, 2, 5, minus 1, 3, 5, another 5, 1, 2, then 1, 0, 0. This is the augmented matrix. We try to obtain the reduced row echelon form, and then we look for solutions, right? And but let's also remember the following. This is the matrix A. What is the determinant of matrix A? If we try to simplify this, we get here 1, 2, 5. This is 0, 5, 10. I think we did this somehow. And this would be 0, 1 minus 4 minus 3, 4, 5 minus 5. Okay, and then, so then the next step would be 1, 2, 5, 0, 1, 2, and this would be 0, minus 3, minus 5. Now, we are trying to find a determinant, but how? By obtaining an upper triangular matrix from the initial matrix, and but actually, the moment that we divide this row by 5, we have changed the value of the determinant of matrix A. Okay, but what we are trying to see is to check whether the determinant of this matrix is 0 or non-zero. Okay, so if we are trying to do that, we can forget that the determinant is going to change here by some factor. And in this case, what do we produce here? This is 1, 2, 5, 0, 1, 2. And the last operation is what? We add to the third row 3 times the second row. This is 0, 0, minus 1. Okay? So what is the determinant of this matrix? Here, the matrix is now upper triangular. If we have a matrix which is upper triangular, the determinant is equal to the product of the diagonal terms. Okay? So we just want to figure out that if we notice that the determinant of A is different from 0, if the determinant of A is different from 0, then we can always find a solution x for which A times x is equal to B, for any value of B. Okay? So this means that matrix A, it can have this 1, 0, 0 in the range of A2. Sorry, A2 has this one in its range, which means that the linear combination, we can find values x1, x2, and x3 such that the linear combination of these three columns gives this number. But are you too much surprised about this one? I believe you should not, because A2, this can span the three-dimensional space. Okay, so we should not have doubts on this one. Is it? Does this ring a bell? So the range of A2, it was larger than the range of A. Okay, and A2, sorry, A was a plane. Now this is a volume. So any vector can be in the range of A2. Why? Because we have three columns that are completely linear independent. If we had only two, we would define a plane. If we had three, we define the whole volume. And now if the whole volume is defined by a triplet of numbers, we can go anywhere we want. Okay? So similarly, we can also say the following, that 0, 1, 0 is in the range of A2. 0, 0, 1 is in the range of A2. And if this is the case, any number A, B, C, this is also in the range of A2. Why? Because this is a three-dimensional structure. Well, when we say three-dimensional structure, this can cover completely the 3D space. Absirën tre-dimensionale.
So, Professor, to sum up, if the range of 2 greater than 1, that means that it has infinite solutions, or what again? And it is a volume, and inside this volume can enter a plane. What does this mean?
Okay, let's see this one. So let me try to clarify this way. When we're asking the question whether a specific vector is in the range of, let's say, matrix A. So let's have this matrix A2. Let's consider this matrix here. What does this mean? This means the following. Can we find a vector x such that when we multiply this with the vector x1, x2, and x3, can we find these numbers such that we get here 1, 0, 0? This is the same way. So does this equation have a solution? And is this vector in the range of A2? This is the same question. Okay. So these two at the opposite corners of the board, they are equivalent questions. Does this have a solution, and is this in the range of A2? Now, when we ask whether this has a solution, let's not forget the theorem we did in the first session today. We said AX is equal to B has a unique solution if the determinant of A is different from 0. So it looks like A2 can describe any vector. Why is that? Because A2 can span the three-dimensional space. Okay, this is how I can formulate it. And I think what you said when you were asking the question to me before 1 minute, you said it correctly. It was correct what you were saying, but maybe you just said that you have an infinite number to define, etc. So probably we can say that any point in 3D or any vector, so you can come up with prime numbers, 13, 17, minus 71. This is in the range of A2. I have no doubt. Okay. Sepse a dyshje skanon gjithë hapësirën tridimensionale, mos dyshoni fare për atë punë. Okay? And why is that? The reason is that the determinant of A, which we can denote it like this, is what? Is different from 0. Okay? And I can also say the following. If we've got something like this here, what is the reduced row echelon form of A2? Reduced row echelon form of A2 is equal to what? is equal to identity matrix, right? And so are we good so far?
No questions.
Okay, then try to follow me one more argument, which is the following. I can ask you this question. Assume for a moment we have this matrix 1, 0, 0, 0, 1, 0, and 0, 0, 1. So forget, we have on the board A, A1, A2. Let's call this one A3. Okay, now we can ask any question. We can ask the following question. So here we have A3. The question is 13, 17, 71 in the range of A3? What can you say? Can you answer this? We're asking, is this in the range of A3? We say yes. Why? Because we can write this 13, 17, 71 as a linear combination of these columns, which is 13 times 1, 0, 0, okay, plus 17 times 0, 1, 0. Are we clear here? Plus 71 times 0, 0, 1. So if we can find such numbers that will produce this number from these three columns, then we can say that this is in the range of this matrix. Would you agree with this? Why? This is even easy to notice because you just multiply 13, you get 13. 17, you multiply this y component, and the z component 71, you multiply by 71, and this is pretty much obvious, right? So, if this is the case, we also consider the following. Or I can ask this one. Is minus 1, 1, 0, is this in the range of A3? What do you think?
Yes.
Yes. And don't forget, this 1, 0, 0, 0, 1, 0, and 0, 0, 1, this is like the x, y, z. The Cartesian coordinate system, x i ky është, x është nish 0, 0, y është 0, nish 0, z është 0, 0, nish. Pra, nëse ne kemi dyshime që sistemi kartezian nuk skanon gjithë opsionet tridimensionale, atëherë që ka problem këtë, nëse pasi më vure më përpara. Por x, y, z-in e përdorin në inxhinieri, në inxhinieri ndërtimi, në konstrukt, në shumë gjëra që shkollë 5, shkollë 8 vjeçare kemi përdorur, dhe kemi qenë të kënaqur që x, y, z e bën këtë punë. Dhe nëse x, y, z e bën këtë punë, edhe kjo atyshi që është këtu, që ka determinante ndryshe nga 0, if the determinant of A2 is different from 0, let's think for a moment like this. If the determinant of A2 is different from 0, what does this mean? This means that the reduced row echelon form of A2 is equal to what? Identity matrix, right? So what we can do is that if we start from this matrix, we produce the reduced row echelon form, we get this. If this one can scan, and the thing is that the space that can be spanned by this matrix is the same with this matrix. Why? Because this is the reduced echelon form of this one. Okay, so is it clear?
Yes, this part is clear. I wanted to ask you about the question we solved a few minutes earlier.
Okay.
You put two matrices and you asked whether or not the column vector 554, you asked which one spans more range, which one has more range.
Yes.
And we concluded that their ranges are equal.
Yes.
Because 554 was part of the other two. But how can you just define that argument again? Because I didn't understand it.
Yes. So this is matrix A1, which is constructed by this vector, which we have taken it from matrix A, right? Then, if we add the first column with twice the second column, we get 554, right?
Okay, so 554 is a linear combination of the first two.
Yes.
Columns.
And the thing is that the first two columns, they are in a plane. Okay? They are defined in a plane like this. You define it whichever way you want. And then the 554 is still in the same plane. Okay, so you are in two-dimensional space. You have two vectors. That's enough. You don't need a third. I can make up also another. I can also add the following. Help me here. So what is the summation of the first column with the third column?
6,
Yes.
4, and 6 again.
So did we increase the range of the matrix A now?
No, because it's it's redundant.
It is redundant because this vector is still in the same plane. It's not producing anything new. You can add like this. You can add more columns, but we are not. If we are getting new columns from the linear combination of the previous ones, we are not adding anything new. Okay, so the range does not change.
Okay, thank you, Professor.
You're welcome. Okay. Okay. Anything which is not clear?
Still not, Professor. So to sum up, we just pick a row and we see if we can obtain that row according to the matrix. To see if it's in range or not.
Can you repeat this once again because I kind of missed. I could not hear you exactly. Say it again.
So, for example, an exercise would be to pick a random row, for example, 3, 6, 7.
Yes.
A column, and then according to the matrix, we if the column is in the matrix by doing calculation. We can obtain the column according to the matrix, right?
Yes.
Okay.
So we use the columns as elementary vectors. Okay, it's like coordinate system. It's like this is how we can define it.
Okay, got it. Thank you.
Okay, you're welcome. Okay, if you don't have any more questions, we can close it here for today. I thank you for your attention.